All right, in the next part, um, we are supposed to estimate the error of estimating our function 1 over 1 plus 1 over square root of 1 plus x with its Taylor polynomial of degree 2, right? Now, so I have just copied the um, Taylor series itself that we derived in the previous part. So for your reference, now um, to do this, we need to use the formula from the lecture. So the error, sorry, let me change the color. So the error is going to be, if we use, generally speaking, if we use, say, n terms, then the error is the absolute value of uh, the derivative of our function of order n plus 1 evaluated at some point c divided by n plus 1 factorial times x minus a to the power n plus 1. And here c is between, basically, c is between essentially a and um, and x and x plus minus a, whether it is on the left or on the right. So in our case, a is just 0, right? So in our case, so our error is the absolute value of what? We need to take basically the derivative of our function of order 3, right? So since n is 2, so and in the error estimation we have n plus 1, so it's going to be the order 3. So in other words, I need to look at this term um, with n equals to 3, and to estimate the error I use the absolute value, so I don't need the minus 1 to the n. So order 3 means that it's going to be 1 times 3 times, I guess it's going to be 3, the product of 3 odd numbers, 1 times 3 times 5, divided by 2 cube times 3 factorial, um, times, well, 1 plus, so I've got to use this derivative, so it's going to be 1 plus c raised to the power minus 2, sorry, um, 5 here, so it's going to be minus 7 over 2, right? Yeah, times x. Okay, so this is less than, or less than, so x is less than 0 0.01, right? So we know that x is 0 less than 0 0.01. So the what remains is to figure out how to estimate this 1 plus c, and and we know that c should be between 0 and x, right? So c is essentially, well, in our case a is just 0, so c should be between 0 and x. C is between 0 and x. Well, so what is the, to estimate this from above, we really want to ask, so what is the largest possible value of this term is? And then if you think that this is a function of c, then as a function of c, it is, okay, so 1 plus c is an increasing function, so 1 plus c raised to the power minus 7 over 2, since the exponent is negative, so it is a decreasing function. So, and since this is the decreasing function, it achieves its maximum for the smallest possible value of c, right? So 1 plus c raised to the power minus 7 over 2 is maximized when c is minimized, when c is the smallest. Well, and c, when c is the small, so when does it happen? So c is between 0 and x, and the largest possible value of x is 0.01. So essentially it means that what to make c the smallest, so the smallest possible value of c is minus 0.01, right? um, so which means that to make this as large as possible, so this is going to be still less than 0.99. So, and this is, so the overall, the whole thing is less than 1.3.5, 1 times 3 times 5 divided by 2 cubed times 3 factorial times 0.99 raised to the power minus 7 over 2 times 0.01. Well, you can compute it if you want in closed form, but that's basically the answer.